In this video, we are going to discuss a little bit about vectors. So here I have that a scalar quantity has magnitude only. For example, speed is equal to 50 kilometers per hour. So you can see here that when we state the speed of an object, we just give the magnitude only, 50 kilometers per hour. So 50 kilometers per hour is just the magnitude. But a vector quantity has both magnitude and direction. For example, velocity. We have the same magnitude of 50 kilometers per hour, just like speed, but now we have a direction attached to it. So 50 kilometers per hour is the magnitude and north is the direction. So now you can compare the two and you can clearly see the difference between a scalar quantity with magnitude only and a vector quantity with both magnitude and direction. So now an arrow is used to represent a vector. The length of the arrow gives the magnitude of the vector, and the arrow points the direction of the vector. So here I drew an arrow to represent a vector, and I'm going to call that vector A. So A is the name of this vector. So the arrow is pointing in this direction. So the base here will be called the tail of the vector, and the top here will be called the head of the vector. So this vertical distance here would be a y value. So it's just like the Cartesian plane where the vertical axis is the y-axis. And this horizontal distance here would be an x value. And it's just like the Cartesian plane again where the horizontal axis is the x-axis. So I can represent my vector A as a column matrix with the x component first and then the y. Now remember, the arrow points the direction of the vector, but the length of the vector gives the magnitude. Now what we can see here is that we have a right angle triangle, and we can use Pythagoras' theorem to get the length of the hypotenuse, which would be the magnitude of the vector. So if we draw a line from the right angle, it would touch this side of the triangle, therefore A would be the hypotenuse of the right angle triangle. So applying Pythagoras' theorem, we would have A squared, because that's the square on the hypotenuse, and the square on the hypotenuse is equal to the sum of the squares on the other two sides, and the other two sides will be y and x. So I'll have x squared plus y squared. So now A will be equal to the square root of x squared plus y squared. So the magnitude of the vector A, or the length of the vector A, is equal to the square root of x squared plus y squared. So once I put these two lines on either side of A, that would stand for the magnitude of the vector A, which is the length of the vector A. So now we'll go on to look at how to represent vectors on the Cartesian plane, and also work out the magnitude of vectors. So here I have my Cartesian plane, and I'm going to draw the following vectors. So first, let's start with vector P, which has x component 2 and y component 4. Now this vector P is known as a displacement vector. That's because the tail of the vector can be anywhere on the Cartesian plane, except the origin. So I'll just mark a spot where I'd like to put the tail of this vector. So let's do that right here. So this is where the tail of the vector P would be. So we'll follow the rules of the Cartesian plane where positive x would be going to the right and positive y would be going upwards. So positive 2 and positive 4 would mean 2 on the x, that's 2 to the right, and 4 on the y is 4 upwards. So I'll go 2 units to the right, so 1, 2, and then I'll go 4 units upwards. So 1, 2, 3, 4. So here I'll have my displacement vector P with 2 units on the x going to the right because positive 2, and positive 4 units on the y, so we went 4 units upwards. Now bear in mind, this is the tail of the vector and this is the head of the vector. So when we are drawing a vector, we start with the tail first. And again, this is a displacement vector because the tail of the vector can be anywhere on the Cartesian plane except the origin. So now let's look at the vector AB. So this A and this B with this arrow on top means the tail of the vector is at A and the head of the vector is at B. And in this vector, our x component is -2, so we'll be going 2 units to the left. And our y component is 4, +4, so that's 4 units upwards. So I'll mark this spot for the tail of the vector, which would be A. And I'll go 2 units to the left, so this is 1, 2, and that's because we had this -2 as our x component. And now I'll go 4 units upwards because +4 on the y would mean to go upwards by 4 units. So from here, I'll go 1, 2, 3, 4. And this point here would be where the head of the vector is, which would be point B. And notice the arrow on the vector always points from the tail to the head. So now let's look at this vector Q, where we have +2 as the x component and -4 as the y component. So +2 as the x component would mean going 2 units to the right, and -4 as the y component would be going 4 units downwards. So I'll mark this spot here because that's where I want the tail of the vector to be. So now I'm going 2 units to the right. So that's 1, 2. And then this -4 would mean I'm going 4 units downwards. So from here, 1, 2, 3, 4. So this will be the tail of the vector, and at this point will be the head of the vector. So this will be my drawing for my vector Q. So now for the last one, Mn, that means M is the tail of the vector and N is the head of the vector. So the arrow points from tail to head. So I'll mark the spot here because that's where I want the tail of the vector to be. So that will be M. So we have -2 for our x component. So that'll be going 2 units to the left. So from this point M, I'm going 2 units to the left. So 1, 2. And our y component is -4. So that'll be going 4 units downwards. So from this point, I'm going 4 downwards. So 1, 2, 3, 4. So N would be at this point because this will be where the head of the vector would be. So this is N. And this is your vector, Mn. Now, when trying to find the magnitude of the vector, notice that when we form the right angle triangle, all these vectors, even though they have different directions, the sides still have the same lengths. And therefore, if we apply Pythagoras' theorem, the length of the hypotenuse will be the same for all these vectors. Which means the magnitudes of these 4 vectors are the same. So now, let's just work out the magnitude of Mn, applying the formula. So I'll say the magnitude of Mn is equal to the square root of x squared plus y squared. So that'll be the square root of -2 squared plus -4 squared. That's because this -2 is the x component of Mn. That's why we have -2 squared. And -4 is the y component of this vector Mn. That's why for y squared, we have -4 squared. Now, when you square a negative number, you will get a positive number because -2 squared is -2 multiplied by -2. So we are multiplying 2 negative numbers. So we get +4. Likewise, -4 by -4 would give you +16. So we have the square root of 4 plus 16, which will just be the square root of 20 units.